For this question, we have a word problem related to population growth. In 2007, the population of a certain city was 15,405. If the relative growth rate has been 6.1% since 1980, what was the population of the city in 1980? Use the exponential growth model P of t equals P naught e to the kt. So this is the exponential growth model, which we have written down over here. P of t equals P naught e to the kt. Let's take a moment to explore the different values here, the different variables. P naught is the initial amount, the initial population. This P naught, it has a 0 here. That's what I'm calling the naught. And it's meant to mean, it's like a shorthand for saying P at time 0, which we generally write P of 0. So it's sort of like a shorthand for that. And that's why we call it the initial amount or the initial population, because time 0 is the beginning, the initial. K is the growth rate. So we are given that growth rate. T is the time. And this can be in whatever units. This problem, the units happen to be in years. And then P, this variable on the left, P, is the population after that amount of time. So the way that this model works, the growth model, you put in a time, and it's going to tell you the population at that time. So let's read through the problem again and see if we can identify any of the variables in this question. It says, in 2007, the population of a certain city is 15,405. So in 2007, we have a population of 15,405. So this is a pair of information that goes together. This part is going to help us with the time, t, and this is our population at that particular time. Let's keep reading. The relative growth rate has been 6% since 1980. So K will be our growth rate, 6.1%, and we're going to use that in the decimal form. So I'm going to move my decimal place 2 places to the left to get 0.061. So this is our growth rate since 1980. What was the population of the city in 1980? So we're going to use 1980 as our initial time, as our time 0. So our goal in this question is to figure out the initial population P naught, or P sub 0. That's our unknown. So going back to this information that we had at the beginning, in 2007, we have a population of 15,405. What I need to know is what value we're going to use for t. And that t is going to be 2007 minus 1980, the number of years since 1980. So let's work that out. How many years? since 1980. 2007 minus 1980 is 27 years. So in 2007, we have a population of 15,405. P of 27, the population 27 years after 1980 is 15,405. I think we have enough information for us to substitute some values into our model and solve for our missing population. So once again, our model is P of t equals P naught e to the kt, and P naught is our missing value. So we're going to leave that variable alone, and we're going to substitute into the other values. By the way, I haven't mentioned this yet. This e, the e in the formula, is not a variable. E is the number 2.718, and those decimal values continue on forever without repeating a pattern, very similar to how we use pi in formulas. K, we said, was 0.061. Our time is 27 years, and our population at 27 years is 15,405. I can solve for this initial population, this population in 1980, by dividing both sides by e to the 0.061 times 27. So we're going to get the calculator out and type this value in. We have 15,405 divided by any parentheses around my denominator. The E button here is on ln, above ln in blue. 0.061 times 27. And I need to close parentheses for the denominator. So we got 2,967.41, and let's round to the nearest whole number. So we're going to say 2,967. So the initial population is 2,967. Let's double check. Yes. So the population in 1980 is 2,967. Thank you for checking out my videos. Have a great day.